So welcome, thanks for coming. My name is Konrad Malawski on the Akka team, and this is a talk mostly about Akka Tact. Hope you're excited. I am. So, if anyone has seen the thing on the bottom there, this is a pun. This is a very weird reference. If anyone gets the reference, find me, like, what is the joke in this slide? And you find out I have, like, special cookies I brought over from Japan, and you'll get cookies. If anyone gets the reference. Anyway, that's me. Doesn't really matter. Let's talk about Akka. So, like, usually I dive right in, and this time it's going to be a bit more like prep, like why are we even talking about this, and then it's going to be, again, a bit unusual from my previous talks. I used to talk more about very conceptual. This talk will be both conceptual, but also very code heavy, because everybody wants to see what does the new API feel like, is it going to be pleasant to work with, why did we make such decisions in the APIs as we did. So I hope you did have your morning coffee. So I will assume people are more or less familiar with Akka, so we're not only about the concurrency side of things, but also very much about the distributed system side of things. And it dictates many of the also API decisions we make, and you'll see why. A quick reminder, yeah, high performance-ish. We recently rewrote the messaging layer, so the remoting layer. We're up to 1 million messages per second now using the new transport. It's archery. You'll see in a second how to use it. Does anyone use archery remoting already? Not yet. Okay, so something to try out, and I'll show how to use that as a side note. So, the prep I talked about. So, this is from a previous talk I did, but all the other content is new. But bear with me for a while. So Akka started out 2009, and this was just the actors, just the concurrency side of things, right? So up until now, very often people think when they say, yeah, Akka, they mean the actors, right? It's kind of the main thing. But it's not just that, right? We had future implementations back then where everybody had future implementations, and finally, yeah, now we have the standard Scala ones, but at some point Akka had their own, like, you know, everybody had their own, Twitter had their own, still have. Then we added clustering, right? So before that, there was of course a moment where remoting was developed, but remoting isn't really fit for a proper distributed system. You need proper failure detection, right? So that's what the cluster added. So okay, now we're properly distributed. Then we added HTTP because, okay, clustering, that's great. I can talk with other actors, but it's not, you know, I want to communicate with other technologies, right? I don't know, a Python microservice on the other end or whatever. So that's why we brought in kind of the spray guys. We made it Akka HTTP. So we have that story covered. We can integrate with other people. So another thing that came up is, okay, we need to kind of have, if I have an alive actor and I want to, you know, load balance it, but it has state, I don't want to lose that state. So we worked on the persistence modules, which really went hand in hand with clustering, cluster sharding. So we got this way to distribute actors kind of semi-alive and restore them, rehydrate them. Small side note was all of the CRDT work that is still out there. You can absolutely use it, but with CRDTs, you have to always be kind of aware, okay, does my model fit CRDTs? Yes, no, is it the exact thing I want? But also it's the other side of, it's kind of a duality of persistence. Persistence is consistent, single writer principle, and CRDTs are, yeah, like eventually consistent and gossipy. So we have both trade-offs, depending what your latency needs are, what your consistency needs are. Finally, the big thing, streaming, obviously now also part of the JDK, the reactive streams interfaces. We worked on that like 3 years ago and finally ended up in JDK 9+. And of course, Akka Streams implements that, etc., etc. Adding HTTP2, researching typed quite a while. And you'll see typed has been like researched for at least 3 years until we got to this point with the APIs where we're actually confident in it. Then the alpaca announcements, you maybe saw archery, the new remoting. So we reheard a lot of stuff, right? Like HTTP got improvements, HTTP2, streams got improvements, like an entire ecosystem with alpaca. The remoting got an improvement with a full rewrite of archery. With 0 code changes for you, you get a 10x improvement of performance by switching a flag. We even did multi-data center things, but we didn't really touch the core of Akka for a number of years, right? The actors. So this talk is about the actors, where it all began and how we see it moving forward. And also it's about types. And it became kind of a meme to, I don't know, joke about Akka hating types. So sometimes you get someone online saying, Akka hates types, trust me, right? Once in a while someone tweets something like that. It's like, but in practice, it's not that we don't like types. I mean, we're all Scala developers, if you believe it or not, and we do like types. It's just that, yes, the core actor thing wasn't very strictly typed because, yeah, it was mostly inspired coming from Erlang, which is like, yeah, okay, I sent items around, I don't care. But if you look at like historically what we were really focused on in the last years, okay, Spray, Akka, HTTP, that's since 2013, literally. Then reactive streams, 2014, up until this day. Alpaca, recent thing. And yeah, Akka typed being researched and kind of evolved since 2014. And during that time, like multiple papers being published which influenced our direction. So it was still our focus, it wasn't, we didn't arrive at a thing that we felt comfortable to call it the new main thing. So when you look at it, yeah, all of this is typed, right? Streams are typed. Spray, Akka HTTP, fully typed. Most typed HTTP model in the entire ecosystem, I would say. Akka typed, finally getting there. So, why do we need it? Yeah, of course, static typing helps you with compile time safety. You get more checks, you make less mistakes, but you also do less like weird debugging of concurrent distributed system because something went slightly wrong, right? So it's more about understandability than anything else. That's the papers I mentioned. So Philip Wardler's paper and very interesting, the reactors paper. So Alexander Prokopets and Martin Oderski, if you're interested, was slightly influential for what we arrived at. But let's go and see what we actually changed. So, actors. The usual complaints from the serial guy. You can send the wrong message, right? And people very often claim that this is the first thing that comes up, right? Oh, I can send the wrong message. This is not the biggest problem, honestly. If you send the wrong message, okay, it pops up in unhandled messages or in dead letters, and you're like, okay, I found it. It is annoying, but it's not like the main problem with actors. I would say the navigation aspects, you inherit a Akka code base from a different team and you want to understand what the hell it's doing, but yeah, there's a plain actor event. I don't know what that is, right? What protocol is that speaking? So it's more about by looking at the source code, can I understand what I can do with it? It's not as much about, oh, I sent the wrong message, because that's when you're developing it, you have it in your brain. It's more about handing it to other people. Then, of course, the mutable state dance with sender, which is mutable, and futures was always a bit of an unpleasant thing to do. And the other claim was, actors don't compose, which is kind of true, right? You could say that, yeah, you can do like this chain of actors and they send each other messages by proxying, but that's not what people mean when they say that claim. They mean it doesn't compose the same way as I can compose, be it monads or plain functions or whatever, right? I can't wrap them, I can't combine them, which is absolutely valid complaints. And I'm adding 3 more complaints, which don't come up as the main rant online, I would say, but for us, we see them as something we can improve now when we do this kind of bigger change. So it's flow control. Actor messaging is not flow controlled at all, which is why we did kind of the reactive streams, Akka streams. But what about bringing back some of these concepts back to plain actors? Supervision is very often abused. People read the first time about Akka and they see, oh, there's a supervision thing. So they use it for everything and will never use, a try object. They will never use a try catch, which would have been perfectly fine and even better than like resorting to the supervision mechanism, which is more for things are really going bad, like the thing is exploding. Try restarting. And actor selection being also very much abused. So we'll see about all of these 6 things, how we address them. And no, these are things we will not pursue. So actors are not intended to be completely magically pure. They are intended to have mutable state in them. That's what they do. They encapsulate state, which can be totally a var. That's the purpose of it. And it's also not going to be like the high performance in the sense of like kernel bypass, crazy things, high performance, computing in the real sense of the word, like people with supercomputers, right? It's high performance enough. So if we can do a trade-off, that means it's going to be so incredibly more useful and understandable versus it's the fastest thing on the planet, we will make the thing that is both fast but also usable. Because you're in a distributed system, it's hard to understand those things. We want to make them fast and understandable. It's easy to make a fast thing that you can't understand. And we will not build only for the local case. That's like a core principle. Everything we build has to abstract nicely into the distributed setting. So, summary of untyped. We call it classic. Now we'll start referring it to Akka classic, actors classic. So that's the summary of the main complaints, right? The sender is kind of propagated automatically, so we can't type it correctly. Any message to any actor, the def receive, partial function, and any to unit, right? That's the usual complaint. So what do we do in... Oh, sorry. Messed up the animation a bit. So, a sender is part of a protocol. It's not a method anymore, so it can be properly typed. This is how you would do it. And behaviors always return behaviors. People always had this confusion in Akka Classic where they kind of like the finite state machine API, but it's kind of this thing on the side, and you'd have to decide, yeah, do I do the finite state machine? Do I do the actor with become? I'm very confused. What should I do? So now, basically everything is an FSM. So sometimes people ask, yeah, will you be porting finite state machines to Akka typed actors? Well, no, because everything is now a finite state machine. Reminder if anyone has forgotten how an actor looks like, with the red things being the not nice things we want to improve. So, actors and types, finally. So this is the long intro I talked about. Kind of finished, and we can see some actual meat. While we're at it, like module naming, we talked a bit about it in the team, and the way we're going to talk about the modules is Akka actor typed, Akka stream typed, Akka cluster typed, because the goal is to eventually all the typed things to be the main things, right? So then we can just slash off the typed suffix. It's going to be less weird than having Akka typed actor and Akka typed cluster. It kind of made more sense for us. So if you're looking for artifacts, Akka thing typed. And yeah, is it all about the actorref? People would very often say, yes, we want the typed actorref, right? That's the thing we want. The reaction is usually, oh, this is shit, and oh my god, right? But I love this comic, by the way. Do visit the website. But I will argue that actorref is like, oh, okay, it changed a bit. It is not the main change, and it is not the most useful change. The biggest change, and kind of the thing that outshines all the other changes, to me, is this behavior concept, which can properly compose in the kind of functional meaning of the word, which was the third complaint in the list, but to me it's probably the most important one. So yeah, actorref T solves the first complaint, that yeah, sends wrong message, and it also solves the hard to navigate code, right? Which is to me the more important one, because we work with a bigger code base. I don't know. I go to a customer, they show me the 5 million lines code base, and I'm like, yeah, I see what you mean with it being hard to navigate. It's not that we've been living in denial. We know. So, first actor. So this is how you create an actor system now. And you will notice that, and I will probably want to point at stuff. Let's see if I can figure it out. Is there a mouse? Yes, yes. Okay, so when you start an actor system, you already can give it a behavior. So in classic, the root guardian, so what does all the supervision for all the other actors, for the top level actors, was kind of special, and it was handled by Akka. So in typed, you kind of give the user guardian, which means that this is the place where you can start all your actors. And I actually think we will simplify it so you can do a spawn on an existing actor system. The reason we didn't do it is kind of our internal wanting to not have any locks in the entire code base. And starting top-level actors is like one of the 2 places in the entirety of Akka which has a lock. So we were like, yeah, we will not have locks anymore. But the usefulness outshines it, so. And yeah, where is this actor? I said, yeah, you give the actor system a behavior, and turns out, well, the actor system is an actor. Just wasn't a very useful one because we typed it to not used. So yeah, you can send it the not used message, okay, but it's gonna ignore it anyway. So this is to showcase that, yeah, you can't send it the lol string. You'll get a compilation error, and like, oh my god, like 10 years of research was well worth it. Oh my god, these smart people, Jesus Christ. I know it's funny, like took a bunch of years to get here, right? We know. But let's talk about an actual case. So this is how you would normally build things. So instead of extending an actor, now this is the more functional style, and I'll show the other style as well, which is easier to migrate to if you have existing actors. So an encapsulating object, you're not supposed to have state in it, right? Because that would be, shared between all the actors. And then, yeah, you create this behavior, okay? And here we see this style of the FSM thing where you have the state and you pass it around to each next behavior. We kind of adopt it as the main thing. So, okay, when you create a scheduling master, so context spawn scheduling master, that's the apply. It says, oh, this behavior with empty set. Okay, so it doesn't have anyone registered yet. And when it receives a message, register, of course it's typed properly here, it becomes the new self, kind of, right? It changes its state in a kind of pure fashion because it keeps becoming this new state. Another change, we changed the method name. So now it's spawn and spawn anonymous. I don't think I'm showing a spawn anonymous explicitly here, but this is an important change as well, because we keep telling people you should name your actors, right? And everybody's, oh, I don't care. And then all the names are like $A, right? The entire system is $B and $A, and you look at the system, I don't know what it's doing. So now this is kind of enforced. The spawn will make you give it a name. And if you want to not give it a name, you have to spell it out. Yes, spawn anonymous. I know what I'm doing. Invent a name for me. Small changes, but I think very important. So, behaviors is this collection of factories for behaviors. And a behavior is literally what nowadays would be the receive function in an actor, right? And we have a number of receive versions, kind of feels familiar. And the biggest change perhaps is that because you're in this pure style, so if you do receive, you get both the actor context, which is properly typed as well. That matters for things like ask and similar things, and the message. But sometimes you don't care about the context, right? You just have a pure function which does a thing to the message, forwards somewhere, or just changes its state. So then you can say receive message. So everything has like, the receive methods have two versions always. So it's receive message partial, which is closer to the current receive, right? Partial function. And I'm sorry for the beeping, but it seems I can't change it. Well, other behaviors, that's not a full list. That's a pretty much full list, I think. And this is really core. So everything is now expressed as behaviors. For example, how do I stop my actor? Well, the behavior of a stopped actor is that it's, it's stopped, right? So we return the stopped behavior versus what previously was the case, you'd say, yeah, context stops self, right? So it's, again, the same concept for all behavioral changes. Okay. Other things to note, coexistence. So yes, typed actors can coexist with an untyped actor system and untyped actors. In fact, there's currently running on a emulation layer. So when you start currently typed actors, they are actually running on a untyped actor that has like an interpreter for the typed things on top of it. This has like ups and downs. The up is, well, it's the proven actor system implementation, so there's not going to be crazy memory visibility issues suddenly, right? So we want to help you migrate from existing code to typed systems and feel confident about it. And yes, there existed a complete new actor system implementation, and we would get very nice performance improvements from it, like 20–30% without changing anything else, just some of the internals there. But we thought, well, let's first get people over with a nice migration path, and then we can introduce the new actor system. So, behavior. Behaviors compose, which was the biggest complaint, right? Actors don't compose. Well, behaviors do compose. So behaviors can not only be the stopped or same or receive, they can also give you more capabilities. You can think about it like in Akka HTTP, you have the routes DSL, so it's not as crazy as that, no implicits at all here. But you can wrap and get more capabilities inside the wrapped thing. So for example, when you have your receive message, and you can't really do much, you can maybe have some state, etc., but not more. So then you think, I need logging, I need to spawn actors, how do I spawn actors? I need the context. So you can either do the receive, where you get the context, or you can say, well, I'm going to wrap it with the setup, and setup gives you access to the context. So setup is replacing the pre-start, right? So literally what happens here is Akka typed is looking at the thing and saying, oh, it's a setup. I will run that piece of code in the setup, and then I will keep interpreting whatever was returned inside. So it's really always interpreting the last returned behavior. So setup is like pre-start. But when you say, but I need timers. Yeah, what do? You're like, with timers. And you get a timers object, which you can access. And they compose in any way, shape, or form you want, right? In the middle of your code, when you return a new thing, you could say, well, here I need timers. So you can just say, yeah, behaviors, give me the timers. So it composes nicely, and like each version of the wrapping, it doesn't matter which order you do it, it all works. So no weird cases about, oh yeah, setup has to be on the top. It all works in either way. So, how about reusing those? Because that was, yeah, okay, I can wrap stuff. It's not super exciting. That's like wrapping functions. That's a step forward, but how about reusing things? So, not the most exciting example on the planet, and maybe a bit small font. So I'll try to zoom a bit. So just a ping protocol, there's like ping 1 and ping 2, and you want to handle both, right? But maybe you're handling them separately because they don't even share state or something. So here, the first thing is behaviors receive partial, so it's a partial function. So if it didn't match, then it internally returns a behavior unhandled, which is kind of a last line there. So you can mix partial functions, which, yeah, you can always, or else a partial function, but you can also take a total function, which is the receive message. So that's a total function. You'll get all the compiler niceties about, hey, you forgot to handle X and Y. But you could express the same as a partial function would be with a case underscore, and you return a unhandled. It's exactly the same, but you get the compiler actually help you out because it's a total function. And yeah, you can or else them in any way, shape, or form. As you saw, the state as a parameter, we talked about it. You don't have variables if you don't want them. Some people like that a lot. And we have total functions, so we get more compiler help. So you don't miss handling some message. Now, as you saw in yesterday's Martin's keynote, this is something we would really, really want, but it doesn't exist in Scala 2, right? Union types. When you want to, or else, completely different types, right? I want to handle my, I don't know, pet protocol, but also, I don't know, like parking fees, for whatever reason. And I still want to do it in the exact same actor. Well, it would have been expressed exactly like that, but not in Scala 2. It would be in Scala 3. Nowadays Scala would be like, nein, was ist denn das für ein A oder B? Das verstehe ich überhaupt nicht. And so on. So yeah, we don't have union types. But Scala 3 will have union types, right? So it's like, yes, excellent. So we're really excited for it. So it will just take a bit of time. So we're definitely kind of prepped for it. It would fit the model. It's kind of future ready in that sense. Once we get these types, it just works. But nowadays we don't. Okay, sorry, animation again. So, what can we do until Scala 3 lands? We can do a bit of like type wiggling, how I call it. So, this is a boring version, which is narrowing the type. So this is like an actor that will be a pet doctor, a vet, and it can handle either a cat, dog, capybara, etc. So when we have a behavior that can handle animals, you can narrow it down to handle just a specific part of the protocol. This is interesting when you have a bigger protocol, but only part of it is intended for like a part of the system, right? Not everybody should be able to tell me, kill yourself, like maybe only wife or someone. So you can narrow down who gets the right actor F by narrowing the type of the message being handled. This is kind of a boring case because it's, just works. This case, let me see. What are we showing here? Yes, so this is a cop-out, how I call it, because you see we have the behaviors receive any ref, so you're back to the actors can receive anything, but it's a sneaky way to do internally a bit of nasty stuff. You're handling some other messages and sending some message, and someone else will send you some random message, and you can handle it. At least it's contained in one file, but when you expose the message to the outside world, you say, yeah, but I'm only handling animals. So the outside world doesn't have to see a horrible hack that, I cut some corners. So when I say cutting corners, so what's the proper way to do it? And sadly, it will be more verbose. So with types, you will see that, yes, you get more safety, but you also get more verboseness. So which is why we allowed for this kind of cop-out style. Sometimes it's just easier. So the inverse of a narrow is to widen the return type. So if you have behaviors receive message capybara, so it can only handle capybaras, it's a capi doctor. But then you can say, well, widen the type of accepted messages to all animals. So let's say we have a capybara doctor, but we tell him, well, I need you to treat my dog, you're the only doctor in town, like save my dog. So then we just act like capybara is kind of, like the dog is kind of like a capybara, right? So we adapt the dog to the protocol that the doctor speaks, which is the capybara protocol. And maybe it will work out, or maybe not. In practice, how this would be used is more about, you have your existing protocols. I don't know, it's not your code base even, but you want to remain typed, so you would introduce a type in your code base, which is a wrapper around, oh yeah, that external protocol, because then you control your types. And this is a partial function, so anything you don't handle becomes unhandled automatically. So another way to get around talking with existing protocols, especially when you're going to integrate with an untyped system, you may need this sometimes. Another way, which technically is the right way, but also you'll notice a bit more typing stuff. So you can have a message adapter, which is kind of like what we just saw with the widen. The widen is basically adopting whatever protocol to your internal protocol. So you can have the same but you can create them ad hoc. Inside of the actor, you can say context message adapter, some other protocol, and you map the messages to your internal protocol. So another way to handle those things. Another way, obviously everybody knows the ask pattern. Now the ask pattern, the bottom version, sadly with types it becomes a bit more verbose, right? Because you have the other actor you're asking, right? So that's the request type. So you need to, also because we don't have the sender reference anymore. So when you send a message to this other actor, it has to reply somewhere. So we create an artificial kind of actor ref that will demand the response, right? So this other guy can respond to it. So we provide this function that gives you this actor ref that you're supposed to stuff into your message, or just use an envelope or something like that. And on the response, again, if you want to just receive it as a normal message in the actor, instead of doing the future dance, notice we're not returning future in the bottom version, right? So this will pipe the message back, which we tell nowadays people to do anyway, right? It's a future pipe to self, right? So this is built in. But the pipe to self has to be the proper type, right? It has to adhere whatever you're able to receive. So sadly, you need the map response, right? And it's a try because it could be a timeout, etc. And yeah, so sadly, this very generic ask is a bit verbose. The top one that's specialized in entity refs, so it's basically cluster sharding. We have a bit more information about the type sphere, so we can do all these mappings internally. So you have a nicer signature. But yeah, various ways of figuring out how to talk to other actors and integrate with various weird protocols which are not typed, haven't been thought about being typed before. And a crazy experiment is where we could emulate kind of union types by kind of means of, because we're not just function calls, we have, when you invoke things, right, you just send a message and I have an arbitrary behavior, so it could actually interpret things and kind of route it to the right behavior. But just crazy idea I had while working on the slides here. Not sure if it's gonna work out or not. So, now the other question. What about lifecycle, right? We did see the pre-start. I told you, okay, pre-start is now set up, but how do we do, I don't know, terminated, or post-stop, or pre-restart, you know, all of these kinds of lifecycle events which are useful in actor systems. You can't just receive it in your actor because it receives a type T, and the type T is your protocol. It's not the pre-start thing. So we introduced a separation between messages and signals. And at the same time, we made it more consistent that there's no pre-start that you override, right? Everything was override-based. So like half of Akka was message-based. And yeah, these special things you need to override methods for. Was a bit inconsistent. So now everything is via messaging, but these other things, the lifecycle things, the terminated messages, they are called signals. And the signal gets like its own receive block, which is, again, to work around the thing because we want to allow you to handle any kind of message you define. Again, somewhat of a workaround because we don't have union types, but I think it's rather nice because the difference here is, again, a receive is a total function. I want to handle all the messages that my protocol is speaking or decide that, yeah, this one I'm not handling. Versus signals, you only care about the signals you care about, right? Oh yeah, I'm only using the post-stop. I'm not getting any terminated messages. Why would I have to, in every actor, write terminated? I don't care, right? So this receive signal is a partial function. Okay, let's jump ahead into other topics. So, dead actors handle no messages. This is the deprecation of actor selection part. So, yes, why are we deprecating? And, well, deprecating. Removing in typed. It's not going away in classic. It will still be around, but it will not be ported over to typed. Why is it bad? Okay, let's remind ourselves what dead letters are. So if you send messages to a dead actor or to a non-existing actor, these messages end up immediately in the dead letters queue, right? And then you can log them. Well, they are logged by default, or you could do something else with them if you want. This is different from unhandled. like short reminder if anyone was confused about those two, because they are similar. Because you're sending messages, but it only likes blue, so all the green messages will end up also in the event stream, but not as dead letters, but as unhandled messages, right? Small difference, but it at least means, okay, the actor exists, it's just not handling the message. Slight difference. Now the problem with actor selection is people sometimes randomly concatenate strings to make up the name of an actor, because we're like, oh yeah, just take the first name and a letter and the address and then underscore, and people invent random ways to identify actors instead of passing actor refs around. And there's two things wrong about it. One is, well, you could get it wrong and then you get a reference to an actor that doesn't exist, so you immediately go to dead letters. And the other problem is, we're not even able to express this in Akka typed. Because, okay, someone is giving me a string, what is the type of that actor ref? So people would have to cast, right? They would have to narrow just randomly. And we don't want people to do randomly, I think this one handles strings. So actor selection is dead. Long live the receptionist. Love that movie, but let's see how it works. So the interaction pattern is more or less like that. So you're like, A is like someone who handles T's in, and the receptionist is like, not yet, no, I haven't seen him. Or you could, well, not really or. At the same time it would say, well, but if such an actor arrives, I'll let you know, right? And because this is now not just a method, it's just two actors interacting with each other, you're decoupled in time already, right? You just send a request, if this actor shows up, let me know. So whenever you get the message back, you will get the reference. You could do a timeout as well if you want, of course. And if it finds such an actor or multiple actors, it will return you a listing of such actors with the proper type. And so the way we handle it is by the protocol expressing, so here you have actor system receptionist, so it's a built-in thing, but really just a normal actor. And it handles the receptionist commands, so you can send it commands, whatever commands, register, find, subscribe. Easy, right? So you either want like a single information, what are the actors, or continuously receive messages about who is providing that interface, and people are joining the cluster, leaving the cluster, etc. And you get the listing back, which is all bound together by this service key type. So when you register, someone comes into the cluster, he's like, I'm registering with the receptionist, I'm checking into the hotel. You give a service key, and then when people look it up, they also use the same service key, which carries the right type, which means that the listing can have the right type as well. This is how we bind it all together. So it's like actor selection, but with proper objects instead of strings, like proper identifiers, and typed, and you get the right thing back. And the subscription thing is interesting because let's say you have a system where nodes come and go as they do in Akka systems. And whenever a Akka node joins the cluster, it has one or more such actors which implement some protocol, and you're load balancing between them. So you would get continuously updated if such things happen. Okay. So this is the part about, like, how do I get to Akka typed, right? I want to use it. This stuff looks very different. I'm not sure if I want to rewrite my entire code base, blah, blah, blah. Which is true. So, how to get from extends actor to having types in your system? So we have also another style of behavior. Well, actually there's many styles of behaviors, but this one is called mutable behavior. And the word mutable really implies that this is intended to have like mutable state here as fields, versus the other style where you just become new behaviors all the time. And this is really like a one-to-one mapping with actor, right? Here you have some state, you have a receive, and here you have some state, and it's an on message, it's properly typed, and you do the other thing with returning yourself all the time, which could be behavior same, or you're just returning this, because this is the behavior. So literally this is a almost mechanical translation. You change what you extend, you change the method name, you're typed. So this is what I would recommend to use if you want to become more and more typed in your system. And you can mix and match the styles. They interop even between Java, Scala. Everything interrupts, shares the same type. So, slowly running out of time, as usual, which is good. So supervision. Supervision was, for one thing, always on, right? It always was restarting by default. That's changed. If you want supervision, you have to apply supervision. That's a change. It's also changed where you apply the supervision. You previously applied it in the parent actor, right? So when you start an actor, the parent actor has the kind of block that handles the failures. But as I said, it was kind of abused. Everybody was using it instead of try and either and validation for that matter. And we couldn't implement backup validation with it because it had to be synchronous. It has to, you get the thing, you give a decision, we restart immediately. So we couldn't do backoff. So this is how you do supervision now. You wrap behaviors. Everything in Akka typed is wrapping behaviors. So you just wrap a behavior with a supervision strategy. There is a slight difference here because, yeah, you would do it in the parent because, well, you're about to start this actor, so you're supervising it. But also, the person who is giving you a behavior could prepare some supervision for it. They could say, well, yeah, I know this one could throw like numerical exceptions, but that's fine. And the moment you get a behavior from them, whoever did the library, the supervision is built in. It's carried around with the behavior. And you don't need to care about it. So it's more composable, again. And you can do nesting if you want. So you can supervise this, supervise that. And we can do backoff. So we can do restart with backoff and configure it a bit, etc., etc. So what are the downsides? Slightly controversial, I guess, but the types. It's a mix. We really want them, but it gets slightly more verbose. And sometimes it gets like slightly really more verbose. So that's why we have all these different helpers and styles of building the behaviors. So you can pick the level of kind of safety and purity you care about. Because by the end of the day, you just want to get stuff done and not spend an entire day on figuring out stuff. This is the extra section about the flow control, which is kind of, yeah, what's back pressure, like not killing the other guy. So we have it in Akka streams, right? So we implement reactive streams, blah, blah, blah. You can watch a reactive streams, Akka streams talk if you want the details, but the idea is, okay, we even have it over the network with stream refs. This is a new thing we introduced recently. Let me fast forward a bit so we have time for other things. So we have flow-controlled, distributed ways of sending messages around, but it has to be expressed as Akka streams, right? You can't express the same in just actor messaging. This is how it works. Let me fast forward a bit. Basically, Akka streams basics. And the idea is, well, we have this flow control protocol. We could apply it slightly, not entirely, but with some helpers to the actor messaging. And if you're interested in that, there's an experiment pull request. I'll share the slides in a moment so you can have a look. And yeah, closing up, other news, so not typed, but interesting, I think, anyway. Things we are intending to call stable very soon. So the artery transport, we also did an artery TLS transport for people who need security on the transport layer there, because artery itself doesn't. It's UDP based. We didn't do any security on the UDP layer there. This will change in the future, but so you have a choice. I would urge you to try it out. People did say that we didn't know about it. It gives you really like a 10x performance improvement by just changing this one thing, right? So you just say Akka remote artery enabled on, and you're way faster. We also do compression now. So if you've never seen an Akka actor message on the wire, this is how it looks like. Maybe one back. And if you can spot the actual payload, it's the hello over here, right? And this is all metadata, like who sent the message, what is the type of the message, which serializer to use, who is the recipient of the message, etc. So now we apply compression to it. So we have like a lookup table, we exchange identifiers for all those strings, so we don't have to repeatedly send them over and over again. So it matters a lot for small messages. It doesn't matter really for big messages, because then the payload dominates anyway, but for small messages, that's a nice win. Just wanted to share, because we didn't really blog about it. I think it's a nice thing. So, other things, that's the commercial side, tracing, monitoring. We have like metrics for everything, including Akka streams and tracing for Akka streams, which is kind of weird, but interesting. Every stage you get a small trace, right? These are the small ones here. Tracing for actors, tracing for futures, across nodes, everything. How do you enable it? You say like, yeah, cinnamon actors, trace, done. So pretty excited about those things. The multi-data center thing is worth clarifying. People are sometimes confused. So multi-data center awareness, which helps the cluster a bit to gossip less across regions, etc., that is open source. There was some confusion. People thought, oh, everything is commercial. That is open source. So the cluster being more friendly to multi-DC things, that is open source. The commercial thing is about Akka persistence with replication and conflict resolution. Things to watch, and I'm out of time. Do visit us on Discuss Akka.io if you haven't yet. We replaced the mailing list with it. I think it's going pretty well there. And talks to see if you haven't already. The Zen of Akka talk, like 2 years ago. This is about anti-patterns and patterns, what to do with Akka. And the best is yet to come is, if you liked the map in the beginning, it's an in-depth like dive into why did we do all these modules and how they connect. Mini ebook you can download for free, just bit.ly why reactive. And a mini announcement, we're working on a typed and streams course on Coursera or EDX, so that should be interesting as well. I did run out of time, so thank you very much, and grab me for any questions, I'll be around. Thank you.